and welcome to the last event of Pint of Science Netherlands. I'm Helena, and I'm co-hosting this event today together with Eline, and we're both volunteers for the Pint of Science Amsterdam team, and we're very excited that Amsterdam is closing the festival with today's event. Important for you to know, you can always ask questions in the comments whenever you want, always during the talks as well. And we'll try to answer as many as possible more towards the end of the event. Today we will have two speakers that will talk about a very, and I'm super interested in. It's like a super cool topic: robots and artificial intelligence. First up is Karine, who is currently a postdoc researcher at the Computational Intelligence Group at the Department of Computer Science at the Vrije Universiteit Amsterdam. And her main research topic is evolutionary robotics. And today she will tell us all about general artificial intelligence, what differentiates natural from artificial intelligence, and how far we are from it. Welcome, Karine, and cheers. Very nice to have you.
Thank you. Thanks for inviting me. Let me share my screen.
Perfect.
Do you see it?
Yes.
Okay.
Perfect. Yes.
So I'm going to talk a little bit about general artificial intelligence. Oops, and it's gone. About general artificial intelligence. And it's more like a reflection. So just to bring about the subject, or to invite you to think about the subject and not necessarily bring you any answers. So first reflection is about humans. So the question is, are we free? And there's this old study of 1983 about the awareness of movement or about intention. So they had these people, they had to move their fingers, and then they were asking these people, when did you decide to move your finger? And it was shown that people had decided to move their fingers 0.2 seconds before the actual movement. And then the criticism fell over this study saying, well, this is self-reported, there are loads of problems. Another study came years later saying, no, we're going to do this in a better way. That's not self-reported. And they did it in a different way, and they showed different results. And what they show is that there's activity in the motor cortex before the intention. And then the finger is moved. So something happened in your brain that had decided to move the finger before you realized it. And of course, you could also criticize this other study. We're not here to do that, but that's just a reflection. Are we free, or should we question the nature of our reality? And are we just living machines in a way? And are we special? Well, we do strive, we fight, we plan, we can be compassionate, we can self-heal, so we have cells that recover by themselves to some extent, we collaborate, we get angry, we are creative, we are scared, we love, etc. More infinite capacities that we do have. And I don't know if we're special, but we are definitely complex. So now let's move to artificial life, or to artificial intelligence. And who knows, a rhetorical question, who knows what general artificial intelligence is? We have a book text definition here. Let's quickly read. The construction of a software program that can solve a variety of complex problems in a variety of different domains, and that controls itself autonomously with its own thoughts, worries, feelings, strengths, weaknesses, and predispositions. Wow, that sounds like a lot. That sounds like us, or maybe other animals. And why would we want that? Well, first, why not? It's so convenient. We can think of the classical Ds, so tasks that are dull, dangerous, dirty. Recently, another D has been added, so dear, things that were too expensive before for some people to afford, or even that companies want to reduce costs with. And I took the liberty of adding another D, which is dashing. Why not? I guess there will be no limits to what we could do. So we could save a lot of time of our lives, that we could do all sorts of things, as opposed to walking straight to death, busy with tasks we don't want to do. So high expectations for general artificial intelligence. When we read books, when we watch movies, we want a lot. We believe that there will be a lot. But in practice, actually, there are a lot of limitations. And what we have are pretty much specialist solutions or specialist intelligence systems. Another quick quote: only a small community has concentrated on general artificial intelligence. No one has tried to make a thinking machine. The bottom line is that we really haven't progressed too far toward truly intelligent machine. We have collections of dumb specialists in small domains. The true majesty of general artificial intelligence awaits our attack. So we have to get back to the deepest questions of AI and general intelligence. This is Marvin Minsky. And I guess I have to say nothing else. So examples, we can do image recognition, speech recognition, diagnosis, self-driving cars that combine some of these capabilities, and robots in factories just building stuff. And you could, and that's not a lot. They are very specialists and they're very particular domains. And you could say, well, Karine, is that all that is? Because I heard some very exciting news that things are really progressing fast. So, well, sensational news. First, robot becomes indecisive after implementing 3 laws of robotics. A supercomputer has passed the Turing test for the first time. First robot passed self-awareness test. Facebook shuts down AI experiment after robots invent their own language. And finally, robot attacks and kills factory worker. Wow, that is all very scary and exciting at the same time. But truth is, and you go look into that with more details, it's not exactly like that, right? It's just people writing news and trying to get views. So if you look at, this is one example of my own work. And this is social robots, a pepper robot that I worked with. And it's a simple application. So you can talk to this robot. It's going to ask you some questions. And you can also ask it some questions. You can talk a little bit, but within a very particular domain. And this can be done using something called BDI. So it's a symbolic representation of concepts. And it does speech recognition. It can also do image recognition. I acknowledge that it was a simple application, and there are more complex social robots like Sophia. In 2016, acquired the Saudi Arabia citizenship. Wow, it's a citizen. But maybe it's more like a marketing strategy. Sophia is also working within a limited scope, and it's going to answer something that's kind of scripted, but with a much more vast script, and based on all sorts of data sets. Then you have, so one example would be using knowledge representation to do that. You can do this with a language called Prolog, for instance. You have this this website called ConceptNet, where you can download these gigantic networks of concepts. One example here, it explains itself. ConceptNet is a semantic network. It's used for natural language understanding, and this is a part of artificial intelligence. So you have this gigantic network with concepts relating to each other, and in a way you can kind of query it, and basically you're not doing more than querying something in a very nicely structured way. But is this really thinking? Maybe not. And then you have this GPT-3 by OpenAI. Answers all sorts of questions. What's the life expectancy in the United States? 78 years. What's the meaning of life? This is 42. Well, sounds like repeating things that were read on books, but people also do that. I also do that. So, but is this really thinking? I'm not quite as sure. I don't think so. It's quite limited. And again, it's using some sort of knowledge representation enriched with gigantic all sorts of data sets, like Wikipedia, for instance, and to train a huge model that's going to answer this. Is that thinking? Well, this is amazing. Like Spot by Boston Dynamics, very adaptable robots. This is a video from the Mythbusters. And you can see the guy is using this remote control. It's not really remote control, but it's used to hybrid intelligence in a way so that a human can change some configurations when it sees, okay, it's not going to go anywhere. I'm going to help it a little bit. So very nice. I think this is one of the ways. Probably this type of adaptable robot is the future for this kind, for what we're expecting from generative artificial intelligence, but not quite there, I guess. So is this enough? Probably not. So how can we achieve this? So one possible initial step is to stop over-engineering robots manually and to rely on what made us exist. What was it that made us so complex? And it was nature, right? Nature designed us. So why don't we look at nature and try to copy it somehow and allow it to design intelligence or artificial intelligence or artificial life in general. So one example of that are evolutionary algorithms in which you have solutions for all sorts of things. These solutions are considered individuals, as if you were an individual in nature, and these individuals are evolving through natural selection. So you have one individual, but actually a population of individuals, so you could have one, you have many, and they are evolving, and they go through this loop of crossing over, so like mating and then mutating and then being selected. You can use this for simple, not simple, but like classical problems as route optimization, when you want to deliver several packages to several locations and you want to do the optimum route. You could use that to define the order, but we are not interested in routes, right? We are interested in life, artificial life. How can we create life? Well, using nature as an optimizer, because nature did optimize us. So what is life? Well, I'm not sure what life is. I won't go there, but life requires usually a body and a brain, right? Is there any life that has no body or no brain? Well, I won't go there neither. So we have this area called evolutionary robotics, and we have this other area called artificial life. There's no time to go into details on how they differentiate or how they're similar. But a lot of what happens in evolutionary robotics is focusing on the brain. But we just said, well, we need a body and a brain to be fully intelligent. And there's something in between, and the intersection of them, that's where the goal is, where your body and brain is being optimized or evolved. So 1994, Carl Siemens, with his seminal work, made this first and amazing virtual creatures. They had their body and brains evolving in different environments, and they looked awesome for back in the days. And then 30 years later, we would think, wow, now we must be crashing, but yeah, we are not. 30 years later, the creatures the field has are not that much more complex and sometimes even worse than what Carl Siemens did achieve. Wow, that is a little bit depressing. On the other hand, so this is a little bit of my own work. So what we see here in this video are some creatures that kind of course, in a very minimalistic way, resemble animals that we see in nature. So this is true for morphological features and also for behavioral features. So the way they move, pretty much, and a little bit of the shape of their bodies. And this tells us something about what we're doing, because if we're looking at nature to get inspiration of how to build intelligence, and then we achieve solutions that are similar to nature, this shows we are in the right path. But this similar is this similar. We need to get much more similar, right? So not quite there yet. More than that, all of this is done in simulation, and there are some attempts of evolving both body and brain hardware, but not really. So here you have some examples of what most people don't even test this in hardware, but some research groups do test it in hardware, but they test the very final solutions. The whole thing has been going on in simulation, and they build these final robots and see if they behave as they are expected to. There are some initiatives. There's one in the UK to have this full process going on. So having a robot that builds the other robots, like an arm robot that puts modules together, and this full evolution process can be going on in the real world, but it's still very rudimentary. We're not quite there yet. And this, one of the most amazing things so far, and I think this might really be the future, is instead of using plastic and normal materials? Why not use wetware? Why not use living cells and make robots out of them? So this is work from Sam Krigman, Michael Levin, and Josh Bongard in America. And they use these cells of frogs. So they are heart muscle cells. So they contract. And because they contract, they have a similar pattern to what is done in simulation, which is pretty much just contracting. And depending on the pattern that you contract, you can locomote. So they evolved this in simulation. There's someone cutting the cells and putting them together in the real world, and then they test it. This is very, very embryonary, but it's amazing. It's really, really, really beautiful. But is this enough? Probably not. So how can we achieve it? So I think personally that it has, I don't have the answer, but it has to do to some extent with the level of abstraction that we are working with and that we have to work with. So highest level of abstraction, lowest level of abstraction would be, okay, let's just reproduce a human fully exactly as it is, intelligent, human intelligence, or from a particular animal, or instead of a particular one single human or a single animal, the intelligence of a collective. That could be the case. Well, that sounds like something very difficult. But we could go take it easy and say, no, let's just have very realistic neurons, not necessarily copy the whole cognitive capacities of a human being. Maybe that's also too much. Maybe let's just have neurons, have some neurons and then see what happens. Maybe that's too much. Let's just have a DNA and see what comes out from this DNA. Maybe that's too much. Let's go back to the primordial soup and wait millions of years until intelligence emerges. Probably not the way. I don't know. So the upper you go here, the lower you go here, there are benefits and also negative sides, drawbacks. So there's time. The upper you go here, the quicker you could do this, assuming that you knew everything about the body and the mind of the living beings, a human, for instance, which is the most difficult, I would suppose. You could do this relatively quickly in comparison to going back to the primordial soup and waiting millions of years for it to exist. At the same time, here you go up, you have constrained benefit, while here you can see unforeseen benefit. What does that mean? Well, nature happened only once. It's a sample of one. So we are not quite sure if everything that happened in nature, even though it might be super amazing, we don't know if it's the best solution. So if we go lower to these levels, maybe not that low, but maybe in the DNA level or some combination of these higher abstractions, we may find solutions that nature didn't find, and that would be better than solutions that are currently going on. Finally, we can do here only what we do know. And here we can do things that we don't know how to engineer. So the message is, we don't really know how our brain works. Well, we do know a lot of stuff, but we definitely don't know enough to reproduce it fully. Whereas on the other side, we don't need to know everything. The lower we go here, we don't need to know how it works, but we can just create a system that is able to approach intelligence and self-engineer. So we talked about what are the dimensions that matter for generative artificial intelligence? Well, the level of abstraction that we just talked about, the design space. Well, what are the materials, the building blocks we have to use? What's the DNA structure? How should this DNA structure look like? Should we actually have a DNA structure or something else? Should we, if your individuals are evolving, how should we mate them? And how should we mutate them? And how should we select them? And if we copy some sort of brain structure from nature, which high or low level does it have to be? So we know that the answer is 42, complexity, but we're not quite sure about the question. And maybe it's a combination of all of these questions and other questions we have not thought of. So how can we achieve this? Well, I don't know, but I really hope I can keep on helping to find out. Thank you.
Thanks so much. That was so interesting. I actually have one really short question that came up because I study emotions. So when you talked about the social robot, I was very curious. So could you elaborate a bit more, like what you actually do with this robot? Did you do like a special experiment?
No, this robot, the idea was having it at the food to help to control corona. And to have it reminding people that they should sanitize and checking, and then ask which floor they were going. And the idea was controlling the amount of people on the floors. It could also do some simple things like telling jokes or improvise poetry, just to get people's attention, so that they would keep on interacting with the robot. Unfortunately, because the quarantine became so much more extreme when the robot was ready, I couldn't deploy it, even if it was to help Corona, because the building closed at that point. So it's a lab work in this sense, but the idea was that. So it's not a very complex robot, because the application didn't require that much complexity.
Yeah, I mean, from your talk, I definitely gathered that there's still a lot to do, so you will not run out of work anytime soon.
Hopefully. Gotta pay the mortgage.
Yeah, that's really cool. And do you also plan to apply the robot later on when we're opening up again? Like, do you want to still put it to work?
If it's still necessary. I mean, I'm not sure how the societal context will change. So let's see.
Okay. Well, yeah. So for now, we also have a thank you for your talk, Karine. If anyone has any questions, please feel free to leave them in the comments. We'll be having a really short intermission by having a little quiz with you guys to see how much you know about robotics and AI. So I'm gonna share my screen.
And don't worry, if you have any questions and you already asked them, we will come to those questions later. We haven't forgotten about them.
No. Okay, so if you use your phone, or if you are on your computer, you can go to menti.com and use the code that's on the top here. So it's 35204082, or you can scan the QR code. So I'm gonna give you guys a minute or two to enter the quiz.
Yeah, and actually, Karine and Milan, feel free to also take part in the quiz, because I think so. You might know one or two questions, but the others we came up with, so you can try your luck.
Let's see.
And in the meanwhile, you can also find the link to the quiz in the comments, at least on Facebook already, and so then you don't have to enter the code.
People are giving us thumbs up, so I think that's a good sign.
Yes.
Cool.
Okay, so I'm just going to continue. Don't worry, you can still enter the quiz. The code will remain in the screen. Okay, so we're going to start off with this question. So what is artificial intelligence? Is it programming with your own intelligence? Is it putting your intelligence into a computer? Making a machine intelligent, or is it playing a game? So feel free to put in your vote. So I see 4 of you have answered already. So
it seems to be pretty. Oh no, now we're having some diversity.
Yeah. Is it playing a game? Is it making a machine intelligent? Maybe it's one of the other 2 options. I'm not going to give it away just yet. Okay, so let's have a look. It's making a machine intelligent. So most of you got it right. Playing a game. Yeah, unfortunately, I mean, I think artificial intelligence can be used in games. I wouldn't know whether playing a game really is artificial intelligence. Okay, so let's go to the next question. Which of these programs does not use artificial intelligence? We have Siri, we have the email filter in Gmail, Google Maps, or are we trying to trick you guys and are all of these programs using AI?
I'm wondering whether the first answers that pop up are Karine and Milan because they know the answer to everything. Like immediately clicking the correct one.
Okay, hands up.
Oh, we have one for Google Maps. Yeah.
Yes.
But again, people seem to be pretty similar here.
Yeah. Most of you think we're trying to trick you. One of you is thinking that Google Maps actually does not use AI. So let's see. Yeah, we're sorry. We tried to trick you. We kind of succeeded. I feel like it. But yeah, all of these programs use AI in some sort of way. And then the next question. This is a more factual question. So I'm really wondering whether any of you know this. Like the cells of the first ever living robots were frog cells, snake cells, spider cells, or worm cells.
Yeah, and I think Karine gave a hint to that in her talk, maybe, but only if you paid attention. Ooh, okay.
We're going 50-50.
Hi.
Oh, it's switching quickly. Interesting.
Yeah.
Oh, this is really cool. I mean, I feel like if I hadn't heard your talk, Karine, all of those would be equally likely to me. So I'm happy that I now know what it is.
Okay, so let's see what the answer is. Are you ready?
Last minute change.
It's very close. So it's actually the frog. Karine, could you say a little bit more about it? You just...
Yeah, they were frog cells, in particular heart muscle frog cells.
Yeah. Okay, so next question. What percentage of evolutionary robotics evolved not only the brain and not the body of the robots? Is it 20, 50, 75, or 95%?
Yeah, I thought it was really interesting when you said that you need a brain and a body. And then I started thinking whether there's any counterexamples, whether you only need one of those things. But I have to think about it a bit more.
Yeah,
I mean, if it's just artificial intelligence, then you can just have a brain. But when you talk about artificial life, it's more broad, right?
Yeah.
Yeah. Here again, it's
so
really a race between two of the answers right now.
Yeah.
Okay, so we're going to go to the answer. Fill in your final answer. And it's 95%. And that's really a lot.
Sadly.
Yeah. Yeah, no, that's really a lot. I feel like I don't know exactly like how much, like I don't have a number on how much evolutionary robotics is like actually being done. I also think there's not really a number for it, but I feel like for 95%, there's still so much left to do and to discover. Okay. So what's the name of the robot you see in the image? Is it Megatron, TikTok, Cyberdyne Systems Model, or is it Wall-E?
I guess everybody knows this one.
Yeah, I mean, we were trying to make some questions easier than others. People need, success in their life, so it's nice.
Wow.
No, but we have a little bit of
so
variation.
lock in your answers. Here we go. The answer is Wall-E. It doesn't show, but it's Wall-E. Okay. So, and then we have a more open question to you, to our audience. Would you feel safe in AI-driven car? So yes, no, maybe. Feel free to also leave a comment on why it's a yes, why it's a no, why it's a maybe. I'm also wondering how, Karine and Milan, how you would feel about this.
For me, it's a maybe. I'm not that familiar with how exactly they're doing this, in which stage they are, and I've never seen one myself. But I don't think I would. I don't think I would have a problem with it after doing some check of my own. I just haven't done it yet, so I have to say maybe.
Yeah, I just also saw a comment pop up, like, what about dilemma situations? Would that have influence on your decision? Because it decides to save your life over others?
Yeah, that's an ongoing dilemma, but I can say rather politically for myself, I would feel more safe than with me behind the wheel.
Nice one.
Yeah,
we did have some self-driving buses in Vienna once, but they drove so slow that they couldn't really hurt anyone, basically, because they were going at a speed of like a snail, I felt.
Okay, so I'm really mainly seeing maybes and yeses. Well, of course, here's no correct answer. I feel like this is really what anyone feels like. So yeah, if you have any questions for us, you can leave them in the comments on YouTube, on Facebook. I'll also keep this open, so you guys should also still be able to send in our questions here. For now, I really want to thank you for your participation in the quiz.
There's one question here. Should I read the question?
Yeah. Okay, so we got a question. So, hello, very interesting. Another important prerequisite of life is reproduction. Any research in the direction of robots learning to reproduce, making other robots more efficiently? So, is there research like directed to learning robots to reproduce? I think that's the question.
Yeah, actually,
okay.
Yeah, okay, you do.
Go.
Yeah, actually, that's something that Karine and I started at Freie Universiteit, and it's an ongoing research. So it's not a new topic. There is this field exists of reproducing robots for 30 years, but it's mostly done in simulation. What we did for the first time is robots that are parented by two other robots in real hardware.
Wow.
Yeah, so the main gist of revolutionary robotics is that robots do reproduce in this process of evolution, right? So I mentioned a few dimensions, and one of them was mating. Mating is definitely a concern. How should we do the mating? Should we have 2 parents, 3 parents? How much DNA structure should we get, or genetic material should we get from each parent? How exactly does that happen? How do you combine this? How do they choose each other? How do they fall in love, so to say? This is one aspect. Another aspect is bringing this to actual hardware and having robots creating each other and perhaps developing. And that's a step really far. And as I mentioned in the talk, the efforts in this sense are very minimalistic so far. Proofs of concept have been made, but you don't have a full system actually operating and creating a population of robots that are living in real time. This just doesn't happen anywhere.
Okay, do you see it happening in the future?
It's hard to say. I could be like that. And I don't know, there's a great name from IBM, whose name I don't remember, who said that no one would have a personal computer ever. It was just too infeasible. I don't know.
So never say never.
It could take 50
everything
years.
is possible.
I can imagine that I definitely believe this is going to happen. I think there's no way to stop it, but I have no idea when.
Okay.
I think it is inevitable, although it's not going to take a form as we imagine it. Usually, like completely mechanical creatures made in silico, but rather more in the direction that Karine mentioned with the research with the frog cells, that you have this design organisms that are basically called softbots now.
Cool. I have to Google that later.
Yeah.
But I think so. We'll answer some more questions later in the general discussion. But for now, thanks, Karine, again for this amazing talk already. Oh, now we have a question popped up, so we can keep that one. Yes. So, what about killer robots and the effects of AI on health? Who wants to take that one?
I can mention, that's a good question, and I wanted to mention it for the end, but it's a perfect timing for here. There was 20 years ago, there was designed a robot called a slug bot, and it was designed to go around the garden and hunt for snails. So what it does, it has a mechanical arm, it grabs the snail and puts it in a back compartment where it digests the snail, and from it gets energy source to hunt other snails. So it was interesting system, but when the general audience heard about it, like everybody freaked out. So yeah.
I never met any killing robots. I don't know.
Well, as long as it's just snails, maybe we can be fine with that.
I guess AI is a tool like anything else. You know, there are knives, there are guns. You can use good things, bad things, and there are robots, and you can do good or bad, whatever that means, with all sorts of things. And I think our work is to develop them, and maybe somebody else's work to decide how to use it.
Yeah, definitely. So actually that fits quite well with Milan, who will speak next. So just to shortly introduce you as well. So Milan is currently a data scientist at Stedin, and he did his PhD in the same group as Karine, where he was also working on evolutionary robotics. And today he will focus on so-called strong artificial intelligence, what is needed to get there, and how it influences us as humans. And yeah, cheers to you as well, and looking forward to your talk.
Cheers. Okay. Do you see the screen? Yeah, perfect.
Yes.
Okay.
Perfect.
So thank you all for inviting me, and I will start in general with what is AI and why do we need it? Do we need it at all? And then I will touch upon a bit what do we need to get there. But this is more general talk, so I would also like to address what are we going to do with us at the end. So artificial intelligence has a broad range of applications, from chatbots to autonomous cars. And it is impressive how fast the AI industry is developing and how fast AI applications are becoming an important part of our lives. However, the big goal is to make a machine intelligent enough to handle any general cognitive task, just like human brains. So we call this general or strong AI. And this strong AI assumes next level of machine intelligence that is equal to human intelligence. In contrast to weak AI, which represents algorithms focused on a single specific task, the strong AI would include the ability of problem solving, learning, and development. Now, it sounds really good to have a one-size-fits-all solution, but do we actually need such a powerful AI? And if yes, are we really sure that it will have a form that we imagine? And most importantly, if we make it, how will it change our society? And for good or for bad, let us first see what is the driving force that pushes us to develop such kind of intelligence. So concerns about disruptive technologies are commonplace. Different interpretations mention many benefits that the strong AI can bring us. And of course, every advantage comes with the other side of a coin as well. So for instance, AI can increase automation and optimize efficiency, but it can also have economic consequences to a widespread adoption of machine learning and other AI technologies. And whether there is a net positive for society, whether this is the net positive, it's still debatable. It could also solve complex social issues. Although AI is very promising in this aspect, there are ethical issues and biases we must still expose. It is one thing for machine learning to predict and help solve problems, and it is quite another to use these systems to purposely control and act in ways that will make people unnecessary. But what I see is the greatest need for general AI is that it could help us understand our own nature design. And perhaps most important lesson I have learned during my years of robot development is that the things that seems most difficult, like algorithm design, turned out to be relatively easy, while the things that seem easiest, like locomotion control, has turned out to be the most difficult of all. And many other aspects of human functioning are waiting to be understood. So replicating them in silico could increase our self-awareness, if you will. It may as well be that AI takes a form that we do not expect. So instead of having one smart machine, we may end up with a global supermind composed of millions individual dumb minds in concern. Or a hive mind made of very smart minds, but unaware of it, they are a part of the hive. Or a mind capable of creating a greater mind that can create a yet greater mind, and etc. This could lead to a thing called singularity. And there we enter the realm of transhumanism. So with the sunrise of the internet and ever-connecting devices, we may argue that we are on the verge of becoming a smart ecosystem. And the need for the greater connectivity really exists. But the question is, how far will it take us? But let's track back and look at more practical benefits of AI. About 25 years ago, there was a news articles that were reporting on this exclusive story about the first computer inventor. And what was it all about? Well, it was about a satellite thrust design that is vibration resistant. Of course, the actual what in actuality happened was that the scientists applied an algorithm to a search for a better solution than the standard designs. And they succeeded by applying a genetic algorithm that combines and tests millions of different designs until it finds the best possible solution. And on the left side of the screen, you can see the initial solution, fairly reasonable for a human designer. On the right side, you can see the best solution from the mentioned computer inventor. It does not look like anything we would ever think of, but it is 20,000% more resilient than the original solution. And at this moment, we are not yet close to having real computer inventors. But as my doctoral professor Gusti Abens say, imagine that instead of putting an effort to make a perfect design solution for a problem, if we can design an artificial designer and let him do all the work, that would be even better. And it sounds like a sweet deal to me. But beyond all these learned reasons, human imagination and human competition are the main determinant for progress throughout history. So we landed on the moon not because of the direct need, but only for a sheer tournament. But also we just wanted to see how it is up there. In essence, making a strong AI is unavoidable because it is a bloody cool thing to have. And besides, if we don't make it, somebody else will. Is that right? And now, since we cannot escape it, let's look at some aspects of what do we need to get there. So, firstly, what is always told, we need more data to train our machines. And even humans from birth until consciousness kicks in, we are going through the long process of collecting and distinguishing new information. And for machines, should be no different, except that we could sometimes make shortcuts. Now we have, we at the moment have ever-growing stacks of data that are used for training the current AI algorithms. But and the biggest stack of information about the world is the stock market. And every relatively significant event that happens in the world influences it in more or less on the market prices. So what the stock market is basically a giant computer of the world. But what stock market is missing is what is missing to evolve into true intelligence is this symbolic interpretation of all collected information. And that is a big miss for every algorithm out there, because when a deep neural network labels a cat or a house on a photo, it does not understand, it has no understanding of underlying symbolism. It practically matches a contour of a photo with what might be possibly a cat. So the field of symbolic learning, one of the least developed branches of AI, may be one of the key components for reaching true artificial intelligence. Another important aspect that we overlook is the power consumption. So the brain makes up 2% of a person's weight, but it consumes 20% of the body energy, and it makes around 20 watts of power on a good day. Now, in contrast to that, more efficient processors are consuming about 30 watts and 150 watts are consuming the average ones. At first, it does not seem like a big difference, but let's put this on a more even scale. On average, the human brain has 86 billion neurons. And if you compare this to an average, let's say, Intel i7 processor that consumes 95 watts and it has 1.7 billion transistors, if we assume that what it takes to reach human level of consciousness, the only thing that matters is to match the number of transistors to neurons, that machines would consume at least 5,000 watts, which makes such AI highly inefficient. It also makes the human mind very impressive. However, more data and higher efficiency is not sufficient by itself. And currently there is a trend in AI concerning embodied intelligence or acting machines, if you will. The trend is based on the idea that the machines need to interact with their environments in order to exhibit a more advanced form of intelligence. And at Vrije Universiteit Amsterdam, we went even further. We made the robots that not only adapt their brains, but also their bodies. And to this end, we get our inspiration from nature. At our group, our research group, we focused on evolutionary algorithms. And some 5-6 years ago, we started this futuristic research endeavor that we called the Robot Baby Project. And the idea of the project was to create a robotic system where robots can interact, learn, and also reproduce, also most importantly. And as a result of this interaction and evolution, they could evolve into better robots. In 2016, we presented the proof of concept, the first robot baby parented by 2 other robots. And now, in order to move from the proof of concept to the next level, we need to make the entire population of robots that can adapt and evolve. Of course, for this, it takes more resources and more manpower, or maybe assembly line but yeah, that's for the future. But we are not there yet with, and why is that? Well, this is because we are still missing, in my opinion, the main ingredient, and that is plasticity. So what does plasticity means? Plasticity means creating even more adaptive systems that could interact with their environment and change their structure and purposes according to circumstances. And it also means developing a system that can create a big variety of novel solutions, just like the tree of life in the natural world. Well, arguably, intelligence requires a certain level of adaptivity. So a grand challenge for the coming decades is to develop adapting machines. And this means creating the hardware and the software that can self-develop and self-regulate. And for sure, now you are wondering, is this even possible? Well, like Karine mentioned, with the frog robots, the new technology that is using self-renewed and biocompatible materials are showing promising results. And here on this picture, you can see the artificial made biological machine that is made from ground up. As like aforementioned satellite trust, computers are automatically designing new machines in simulation, and then the best design are built by combining together different biological tissues. So this approach to design a variety of living machines can, I think, broaden our understanding of the diverse forms and functions life may adapt. Okay, now let's wind up down to not get lost in this sea of possibilities for the future true intelligence. Because even without the general AI, all these task-specific AI algorithms are already greatly influencing our society. So let's take a moment to consider all the recorded data about us. Emails, texts, likes, web searches, clicks, Fitbit stats, etc. And the comforting thought, at least for now, is that no algorithm in the world today has access to all the data. But even if it did, it wouldn't know how to turn it into a real likeness of us. But the thing is, they are getting better, and there are already solutions and different AI platforms like Crystal that can give you a fairly accurate personality profiles of a person just from the LinkedIn profile info. And very soon we would have our own digital twin that can understand us better than we understand ourselves. So my main concern is not that the data availability and all the knowledge that we extracted about us, that's also an issue, but rather the main concern for me is the delegation of our responsibility. Because as the machines become more reliable, there is a danger of us processing less and less of information, because it already happened with our ability to memorize things since the beginning of internet. And now with AI, the more we start to trust our AI applications, the last ability that distinguishes us from other organisms, the ability of rational decision making, may also fade away. And we already have the hints of such a process in the form of public opinion. And there are numerous news and discussions about the electoral process recently and how social networks are influencing the outcomes. But less known is that more and more news articles are AI generated. For instance, AI can form complete articles that are undistinguishable from ones written by humans. And not only that, it can generate multiple articles, each with a specific emotional charge, and then do cold testing on its audience. Eventually, it can get only articles with, we can get only articles with high emotional potential, and those articles are usually with negatively charged news stories. So the most uncomforting outcome for me, as I see it, is the world of AI matrix. If AI eventually create our if we manage to create our digital twins in AI, it can also create perfect virtual worlds for us. Just the right one that suits our individual needs. And as the job market starts to compress because of the higher automation, we may see more and more people would free willingly join such virtual worlds. this would also mean the slow fade of our societies. So I hope there would still be people that would like to remain in the reality, but even it may not be everything so dark as it appears. For instance, nature-machine symbiosis may easily be the next step in our evolution. So, for instance, we can enrich machines with features that life does not have. So let's look at the natural evolutions. We all know that offspring cannot inherit, our offspring cannot inherit learned skills from their parents. But for instance, the ability to fly a plane, play a piano, or speak a language cannot be given by birth. Well, the fact that something is impossible in nature does not mean it is impossible in artificial systems. And a few years ago, I did numerous experiments where robots could inherit the knowledge of their parents. And the resulting system adapted faster and the robots became smarter. So this demonstrates a new tool and also raises hope. And as we move from the machine learning to basically learn machines, we should also consider emerging ethical questions. For instance, how will all this affect us? And will we become obsolete? And will life become on Earth obsolete as well? So I am a careful optimist, and safe and controllable AI should be primary concern, and we should address these issues, especially now before they become too late. And until now, every new technology we developed was accompanied by the regulations and tool to prevent its misuse. So you can take, for example, the internet. With the emerge of internet, spam mails become a never-present inconvenience, but then we applied AI to cope with this problem. But I'm also a careful optimist, and I think we should not run away from the future, but also rather embrace it. I just hope in that future we leave some room for humans as well. So thank you.
Wow, yeah, thank you for your really interesting talk. We actually also got a question from the audience that really matches what you just talked about. So what, in your scientific opinion, what is the possibility of robots like in iRobot in the movie, where the central AI suddenly decides to eradicate humans since it's deducted that the Earth is better without us? Like, yeah, what do you think the possibility of something like that is?
I usually get asked the similar question, but I don't see the future where we would have a world from that is taken over by machines, like in Matrix or in Terminator or iRobot. Just because we are over careful with that side of the whole field of AI intelligence. But what I see like as a bigger threat is that we will make ourselves obsolete. So, for instance, I heard this great example when they mentioned 100 years ago we were still using the horsepower for transportation, and then we invented cars as a mean of transport, and now we are inventing something that can make us even obsolete. So yeah, like I mentioned, one of the problem is they may take over, but not in a day, but over decades of adapting. But I also see the hope in this on the side that we are highly adaptable creatures, and we adapt with every new technology that we develop. So I hope that we would see I hope that we will see the people that are more tuned in with technology.
Okay, yeah, because right now you're stating we're also being really careful with these kinds of innovations? Are there like specific rules or ethical guidelines or something that you really need to adhere to at the moment, or do those for instance, need to be developed later on?
Well, I think the one rule that we should strictly respect is that we should not give the robots ability to self-reproduce. So that is what our professor was constantly mentioning. That should be a central facility for robot reproductions, because if we ever have this such a glitch, I don't think we can ever recover from it.
Okay.
We have another question from the audience. I'll direct this to Karine, but Milan, feel also free to answer afterwards. It seems the AI field is very fixated on the human brain as a form of intelligence. Do you also explore other domains of life to get inspiration? For example, microbes that can solve puzzles.
Yeah, so there are all sorts of algorithms based on, for instance, collective intelligence, like ants or birds, and even for cognitive process or like brain structures. Sometimes you're based in other types of animals and not just humans. There are all sorts of initiatives. And I guess this was one of the main points of my talk, that focusing on trying to copy human intelligence in particular might not be a great idea. First, because we don't fully understand it. Second, because it might not be the best solution of all. So this is why this thing of finding the right level of abstraction makes so much difference. Where do we go? In which part of nature, which kind of species or which kind of structure, which kind of emergent process do we want to get our inspiration from? And I guess there are people looking everywhere, and this is really the way, not to just focus on one thing and, you know, become super blindfolded, or more like, you know.
Yeah, I mean, to me, it also seems weird to just focus on one organism. So why not take the different organisms, and not only the human, but also animals? And every species has different advantages and disadvantages that maybe we can learn from, I guess.
Yeah, that's true. It's just like what becomes popular is very often what's kind of human based, but that's not the only thing in the literature. Definitely not.
Well, I can also mention that the reason because we are mainly focused on human intelligence is, as we understand at the moment, the humans are the only self-aware creature that exists. So that's why if we are talking about the strong AI, we are trying to develop a self-aware machine intelligence. But apart from that, yes, we can focus on other organisms, and they can be very helpful with solving the pieces of the puzzle, because human brain is highly complex, and it would be beneficial to solve it in part by part.
Yeah, that makes sense. Thank you. So I have another question from myself that I was interested in, because you showed a lot of slides of, you know, movies, there was Love, Death and Robots, and other, like we had WALL-E before. So do you think that the way that robots and artificial intelligence is portrayed in the media or in literature, movies, does this have a negative or positive impact on how the research is viewed and how people from the general public view the field of AI and robots?
No, I think in overall people find it very cool to see or to do. Mostly the media is concerned with these robots that are taking over the world in a day. But yeah, that's why I'm not worried because about that aspect, because we're highly focused on that. But I'm more worried that it can sneak into us. So we just wake up one day, we cannot live without it. Yeah.
Oh, yeah. And what's your opinion on that, Karine?
Sorry, I spaced out a little bit. What was the question again?
Basically, so how, whether you think that the way that robots and AI are portrayed in the media, like in literature or movies, whether this has a positive or negative impact.
I think for the academia itself, it doesn't make a lot of difference because people who are inside, they know how to differentiate it, right?
Mhm.
However, when it comes about writing a grant for funding, sometimes people who are assessing the funding are not necessarily that familiar with your topic, and then the public opinion can make a lot of difference on this. So when it comes to getting money wise, and we all need that to yeah, we need to take that into consideration. So yeah, it's half perhaps.
Wow. Okay. I think it's really interesting. Unfortunately, we're gonna have to wrap up. So I really want to thank you, Milan and Karine, for being here, for giving these really interesting talks. And thank you, Helena, for co-hosting with me. And of course, also to our audience for your really nice questions, for your participation in the quiz. Here we had one more question. Do we have time for one more question?
I think so.
Then let's see. Yeah, what would be your personal best outcome in the future of robotics? And what drives you working or researching on this topic? So maybe let's start with Karine.
But for me, honestly, it's passion. I'm just fascinated about it. So it's more like curiosity drive than practical drive. Or will this change the world or not? I really believe it will change the world. I see no limits for it. I really see no limits. So I'm not skeptical at all about AI. I know it. I think it could even go out of control. It could go really bad, but this does not demotivate me. I still feel like doing it, even if it could go very wrong for us. The best outcome, I don't know. It's hard to say. A loosey-goosey view of a world in which robots and us, they are as complex as us, and we coexist together in harmony. Not even humans can do that right now, so let alone robots. But if you ask me for the best outcome, that's the best outcome.
It sounds really nice, yeah. So now about you, Milan?
Yeah, for me, I'm a knowledge-driven person, so I just like to tweak in and see how the things work. So I'm not even interested about making a cool gadget. It's more about how the things would work, and the satisfaction of making something possible is what drives me.
Okay. Yeah, no, that's really cool, really amazing. So I hope that answered your questions. So I'm going to thank you again, Milan, Karine, for being here, for answering all the questions, and Helena for co-hosting with me. And once again, a thank you to our audience for being here, for participating, for asking really nice questions. And this was already the last event of the Pint of Science event of 2021. But we'll be back next year in May, on May 9th. We will start up again, and we'll be hopefully in live events, having another Pint of Science festival. So we'll see you guys then, and have an amazing evening.
See you. Have a nice evening.
Cheers.
See you guys.
Bye.